pressure exerted into a fluid is spread evenly throughout the fluid. And the fluid exerts an equal pressure to another object. Okay. The idea here is if I apply a force and apply pressure to a fluid, it's going to transfer that pressure all the way through the fluid evenly and out the other side of the fluid. Okay? So it's going to transfer the pressure evenly through. So the equation for this is very, 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 very easy. It's pressure in equals pressure out. Okay, an example. 500 kilograms of mass is lowered into a well with a radius of 1 meter. Mr. Rohrbeck is floating on a raft in a connected circular pool with a radius of 4 meters. How much mass could Mr. Rohrbeck have and still be lifted? Okay, so here's the thing. You've got some sort of well here that's connected to a much larger pool. That's not what I want. Where is it? There we go. This is it, I think. Yes. Okay. All right. If I put so much mass on one side, okay, I think I said 500 grams, right? I want to know how much is it going to lift up the other side. So that's what Pascal's principle is. Pascal's principle is if I apply a force in here, how much force is going to be applied to the other side. Now, Pascal's principle talks about pressure. So we put 500 kilograms in here, and it applies a pressure in. There's going to be water on the other side, and it's going to apply a pressure out. Okay, here's what we know. We know that the mass being applied in, so we got a mass of 500 kilograms. We'll call it M1. We've got a radius of 1 meter for radius 1 over here. We've got a radius of 4 meters over here on this other side. Oh, am I doing things? Thank you. Yes, I am. So we'll call this radius 2. Here's radius 1. Here's M1. And we want to know what the mass of Mr. Rohrbeck is going to be. So here's Mr. Rohrbeck over here. He looks a lot, he's very square. So that's why I drew him as a box. Okay? M2. It's hip to be square, indeed. Okay? Okay, first thing we need to do is find the pressure applied to the 500 kilograms. So that's going to be my pressure in. Pressure equals force over area. So I'm applying a force of mg. It's the weight that's pushing down. So the mass is 500. G is 9.8. And I do it over an area of whatever this is. It's a circular well. Area is pi r squared. So pi times 1 squared. So 500 times 9.8, 49,000 over 1 squared is 1 times pi is 3.14 divided by pi. We get a pressure of 1,559.7 pascals. So that's how much pressure is applied in. So how much pressure should be applied to Mr. Rohrbeck? So Pascal's principle says the pressure is applied evenly throughout the entire fluid and therefore out the other side. So if the pressure in equals the pressure out, then if this much pressure is applied in, then that much pressure is applied out. So now figure out how much mass that pressure can lift. So pressure equals force over area. So this is pressure out equals force over area. So the pressure out is 1,559.7 equals force, which is mg, over the area, which is pi r squared. And the radius for 2 is 4. So pi times 16, don't worry, I'm almost done here. 50.26, multiply that to both sides. And divide it by 9.8. Mr. Rohrbeck can weigh 8,000 kilograms. Oh, I'm sure. Yeah, that's what he is. I'm pretty sure. Yeah, 8,000 kilograms. Something like that. Yeah.